Welcome back, fellow nerds. In today's video, we continue with looking at more examples on vectors. So in today's video, we'll look at this one and we'll see how we can go about it. Okay, so stay tuned. All right, let's get into it. So a force F1 of magnitude 6 newtons acts on an object at the origin in a direction 30 degrees above the positive x-axis. A second force, F2 of magnitude 5, acts on the object in the direction of the positive y-axis. Find the magnitude and direction of the resultant. This should be simple, right? Should be very simple. Especially for my fellow nerds. We've been looking at a bunch of questions. This should be easy. All right, let's get into it. Okay, so what do we have? We have F1, F2. We have magnitude 6 newton, direction 30 degrees above the positive x-axis, right? This is 5 newtons. Oh, we'll have to find the direction. Okay, so this is a figure that we've been given. All right, so let's use graphical method. Easier, right? Okay, so this is our xy plane. Okay, so this is your positive, this is your negative, positive, negative. All right, so we are told to do what? F1 plus F2. This is the addition of vectors, right? So graphical, again, we remember head to tail. Those are the simple rules about vectors. Addition of vectors head to tail, resultant vector drawn from the tail of the first vector to the head of the last vector. Okay, let's get into it then. Okay, so force 1 is 30 degrees from or above the positive x-axis, which is just above, right? So it starts to move above to make 30 degrees. Okay, so 30 degrees will be made somewhere there, not to scale, but you should know that should be your 30 degrees, 6 newtons. Okay, looks like that, right? The force 2 is directly from your y, so directly along your positive y. But if we are going to add F1 to F2, again, addition, the head to the tail of the second vector, which is F2. So if F2 is starting from there, which means this is going to be its origin. Okay, this will be its y. Again, this will be its negative x. This is going to be its positive x. This is positive y, negative y. Okay, so how is F2 moving? Along y, along your positive y, but it has been added to F2, right? To F1. So your F2 will be right there, moving to your moving along your positive y-axis, but being added head to tail, exactly as it should be when we're adding vectors in graphical method. Okay, so our resultant will be from the tail of the first vector to the head of the last vector. So this is going to be your resultant vector. Okay, so if you have forces, if you have vectors, and you've been told to find the resultant vector, again, we remember from the previous video. What did we have? We had again, we learned that you have to find components, right? X component and Y component given we're using the XY plane coordinate system. Okay, so for our resultant vector, we'll have to find its component X and its component Y. How? By finding component X and component Y of the individual vectors that we are adding. So F1, F2, again, it will be easier to make a table, right? So table, very easy to do. So Vx, Vy, there you go. Okay, so in the table, so we remember how to use our formulas. We learned in the previous video that our component y, you go with sine theta and the magnitude. All right, then your Vx cos theta with your magnitude, right? So we have to find this is your angle and this is your magnitude. We already know the magnitude for this is 6. So for F1 is 6 newtons, for F2 is 5 newtons, right? The angle is 30 degrees. The angle we have to find, right? Because we've not been entirely told. So how do we find our angle? Okay, so our vector is directly in the positive y-axis. Okay, so like the previous video, we learned how to find our angle. How do we find our angle? Our angle should always come from the positive x-axis. So we are moving from the positive x-axis to meet our vector, right? So we're moving like that till we meet our vector there. So what angle have we made? This is 90 degrees, right? And that is exactly our angle and our direction. So 90 degrees. There you go. So we can now just fix in stuff, right? So we'll start with Vx. Vx for F1. F1. So Vx is going to be cos theta, right? Which is cos 30 degrees. Our magnitude is 60 newtons, all right? So you get your calculator, cos 30, there you go, times 6 newtons. This should give you 5.19, so we'll say 5.20 newtons. Okay, F2 cos, you don't really do this in your exam, right? You should know the rules by now. Okay, F2 cos, the degree there is what for F2? 90 degrees. Our magnitude 5 newtons. All right, so cos 90 is 0. Oh, times 5 is still 0. All right, so F2 is 0. 0 newton. Doesn't really matter. This is your x, right? This is your Vx. This is your Vx. This is your Vx for F1. Let's find our F1 Vy. All right, first we can place this in our box. So F1 has got 5.20 newtons. F2 has got 0. So you can say newtons in there. We can say newtons in there, right? You just cancel it if you've put newtons there. Okay, so for F1, that would be sine 30 degrees multiplied by 6 newtons. For F2, that would be sine 90 degrees multiplied by 5 newtons. Okay, so let's begin for F1. So we have sine 30 multiplied by 6. We have 3 newtons. There we'll have sine 90. Sine 90, which is 1 times 5. Now, which is 5 newtons. Again, F1 is 3 newtons. F2 is 5 newtons. All right. Then we can add, this is our resultant vector. This is 5.20 newtons. This is 5 by 3. This is 8 newton. Okay, so 5 plus 3 should be 8 newton. This should be 5.2. This is your x, this is your y. Okay, in that case, we have our components. How do we find our resultant? Our VR is equal to what? We already know the formula by now. So we have that squared. So VR is equal to x. X is what? Our resultant x is what? 5.20. 5.20 squared plus 8 squared newtons, right? So, okay, calculator, 5.20 squared plus that squared, square root of that should give you 9.54, so just 9.54 newtons. Okay, that is our magnitude, but we've been taught to find magnitude and direction, right? So how do we find our direction? Again, we remember over Vx. So the angle is equal to tan that. What is our Vy? 8 newtons. What is our Vx? 5.20 newtons, right? Modulus does not really matter because it's a positive x, which means this is the angle we're looking for because it is coming from what? Positive x. So 8 divided by 5.2, that, then you say shift, done, open brackets, your answer that is going to be 56.97. So that's like about what? So we just say 57 degrees. Okay, 57 degrees. And how do you write that as your final answer? So you are going to say final answer or resultant vector is what is our magnitude? What is our magnitude? 9.54 newtons. 9.54 newtons, comma 57 degrees from all above the positive x axis. Very important. Or you can go with the compass method, which is still okay. Well, yeah, basically this is about that question. Simple, right? Yeah. Well, we'll look at another question. Again. Let's cement on the data. Thank you so much for staying. I hope you've learned something. We'll continue in the next video. Thank you so much. Bye.